Hello students, welcome back to the classroom point. In our today's class, we shall discuss one of the most important concept in concentration terms, that is molarity. Most of the questions in this trigonometry and in the solutions chapter are connected to the molarity, and in the competitive examinations also the questions are being asked from the molarity. So let us see the molarity concept today. Molarity. It is denoted by the letter capital M. So the definition of molarity is, it is the number of moles of solute present in 1 liter of solution. So number of moles already we discussed in our previous classes. Better to watch that video before entering into this molarity concept. Anyhow, now let us see here. Number of moles per liter of the solution is called as the molarity. So that the formula can be written as M equals to number of moles of solute divided by volume of solution in liter. From this we can derive the units of molarity also. Moles, units are nothing but moles only. Volume already given, liter. So moles per liter, or we can write down this one as mole per dm cube. So 1 liter is equals to 1 dm cube. Now, molarity depends on the temperature. When temperature increases, volume of the solution also increases, so that molarity decreases. So here we can write down that molarity depends on temperature and it decreases by increasing the temperature. Let us see how this molarity has to be used, and usually people get the confusion or the doubt about, can we confine only to the 1 liter of the solution? Yes. Molarity always can be calculated only for the 1 liter of the solution, even though they give the less than 1 liter or more than 1 liter, but we calculate only for the 1 liter of the solution. That is what called as the molarity. Let us take an example to justify this. Example, 2 moles of solute is present in 4 liters of solution. Find its molarity. So solution for this is, see here, molarity has to be calculated only for the 1 liter. 2 moles of solute is in the 4 liters of the solution. Then in 1 liter of the solution, how many moles are present? So that's why you do the cross multiplication. 1 into 2 divided by 4. So 2 by 4 is equals to 0.5 moles per liter. Or else use this formula to solve the question. Molarity equals to number of moles of the solute given here is 2. And volume of the solution given here is 4 liters. So 2 mole and 4 liters. It goes by 2 times. 1 by 2 means 0.5. So molarity equals to 0.5 mole per liter, or else simply you can write down this one as 0.5 m, whereas m stands for the molarity, moles per liter. Let us see how to use this formula in solving the questions. So let us try to substitute the value of n, that is number of moles. Number of moles can be calculated in various ways. So number of moles, if mass is given, weight divided by molecular weight of the solute. If number of particles are given, then given number of particles divided by Avogadro number 6.023 into 10 power 23. Sometimes they give the volume. Then in such cases, N equals to given volume of the solute in liters divided by 22.4 liters. How these formulas have come, that been discussed in the mole concept. Better watch that video once again. So now let us try to use one of this formula, that is number of moles equals to weight by molecular weight, and substitute this value there. So we can convert this formula into M equals to weight of solute divided by molecular weight of solute into 1 upon volume of the solution in liters. But usually in most of the calculations, volume of the solution is not given in the liters but given in the milliliters. Then in such cases, we know that 1 liter is equals to 1000 ml. Then multiply this value with the 1000. So we can use the volume of the solution in milliliters also. So that molarity equals to weight of solute divided by molecular weight of solute into 1000 by volume of solution in milliliters. So usually we use this formula in solving most of the questions. Let us have some examples about this. Example, 3.65 grams of HCl is dissolved in 100 ml of solution. Find its molarity. So the solution for this is molarity equals to given mass of the solute, that is 3.65 grams. Molecular weight of the HCl is 36.5 grams per mole into volume of the solution given here is 100 ml. So it goes 10 times and it goes 0.1 times. So here we can write on 10 power minus 1 into 10 value is equals to 1. Let us take one more example. 40 grams, or else let us take the 4 grams of NaOH is dissolved in 500 ml of solution. Find its molarity. Use the similar concept. Calculate the molecular mass of the NaOH. Why? Because formula is given, and substitute the formula and put your answer in the comment box. Where we can use this molarity applications? Let us see here. For dilution, when a solution is diluted, then how to use the formula? That equals to M1 V1 is equals to M2 V2. Why? Because why we are using M1 V1 means, remember that number of moles of solute can also be calculated by using the molarity into volume of solution in liters. So when you have taken some solution, already solute is present, to that you are adding some extra amount of the water. So here solvent increases but solute is not changed. That's why number of moles of the solute in the previous solution and number of moles of the solute after the dilution both remain same. That's why number of moles we are making equal. So M1 V1 is equals to M2 V2. Here M1 V1 is the molarity and volume of the solution before the dilution. M2 V2 is the molarity and volume of the solution after the dilution. Let's have some examples here. 100 ml of 0.1 m NaOH solution is diluted to 200 ml. Find its molarity. So we must understand the terminology also. Here it is diluted to 200 ml. Means the final volume of the solution is only 200 ml. So here we can write down that M1 value is given as 0.1 and V1 value is given as 100 ml. M2 value to be calculated and V2 value is given as 200 ml. So M1 V1 is equals to M2 V2 and M2 is equals to M1 V1 divided by V2. So M1 V1 value is given here, that is 0.1 into 100 divided by final volume of the solution is 200. It goes 2 times, so that 0.5 into 0.1, so that 5 into 10 power minus 2 m is the final molarity of the solution. Now let us see here. Same question, but if the terminology is changed, how to use the formula? So the next question here is example. Let us make it as 1 in this part and this is 2. Same, I am taking 100 ml of 0.1 m NaOH solution is diluted with 200 ml of water. Find its molarity. So in this part, starting molarity, M1 value equals to 0.1, volume is equals to 100 ml. There is no change in this part. Final molarity to be calculated, question mark, and the final volume of the solution is not 200. Why? Because it is added by 200 ml of the water. Already 100 ml of the solution is present. So 100 plus 200 ml becomes the 300 ml of the solution. So that M2 is equals to M1 V1 divided by V2. So here M1 V1 value 0.1 into 100 divided by 300. It goes 3 times, 0.1 by 3. So let us see here, 0.1 by 3. So 1 by 3. 0.1 divided by 3 is equals to 0.033. 0.033 molarity of the solution, final molarity of the NaOH solution. So like this we can calculate the solutions in which dilution is happening. So now let us see another application. So second application, calculation of volume of H2O added. Here we have seen that 0.033 molarity by adding 200 ml of the water. Sometimes they don't give the volume of the water already added or else final volume of the solution, but they give the final volume of the solution, final molarity directly. They ask us to calculate the volume of the water to be added. So volume of the water to be added can be done in the 2 ways. So volume of water H2O added is equals to final volume of the solution minus initial volume of the solution. V2 minus V1, there you can calculate the volume of the water added, or else volume of H2O added is equals to higher concentration minus lower concentration divided by lower concentration into volume of the solution. Now let us take an example here. Same 100 ml of 0.2 m potassium hydroxide solution is diluted to get 0.1 m of KOH. Find the volume of H2O added. So this simple question, let us see here. Initial molarity. So we can done. First let us solve by using this form. Next we shall solve using this form. So here M1 V1 is equals to M2 V2. M1 value initial molarity is 0.2. Initial volume 100 ml. Final molarity 0.1. Final volume of the solution, we don't know, that has to be calculated. So V2 is equals to, it goes simply 2 times, so that it is equals to 200 ml. 200 ml is the final volume of the solution. Initial volume already 100 ml is there. So volume of water to be added equals to V2 minus V1, that is 200 minus 100 is equals to extra, we need to add the 100 ml of the solution. Now let us see the method 2 using this formula. Volume of H2O added equals to higher concentration, which is the higher value here, 0.2. Lower concentration 0.1 divided by again lower concentration 0.1 into volume of the solution. Volume of the solution taken here is 100 ml. 0.2 minus 0.1 gives 0.1. 0.1 by 0.1 gives the 1. So 0.1 by 0.1 into 100 ml. So it cancel out. Finally, we directly get the volume of the H2O added. So like this, we can solve the questions in dilution formula. Let us see the another application. So here now, for complete neutralization, or else in redox reactions also, redox reactions. So in these two type of reactions, the formula of the molarity is M1 V1 divided by N1 is equals to M2 V2 divided by N2. M1 V1 is the molarity and volume of the initial compound and its number of moles in the balanced equation. M2 V2 is the second molecule and N2 is the number of moles involved in the balanced chemical equation. Let us take an example here. 200 ml of 0.2 m H2SO4 is neutralized by 100 ml of NaOH. Find the molarity of NaOH. So solution, here H2SO4, NaOH, both are given. So let us write down the H2SO4 on one side and NaOH on the other side. So let us make the M1 V1 by N1 for H2SO4 and M2 V2 by N2 for the NaOH. N1, N2 values are from the balanced equation, so that we need to write down the balanced equation for this. So here H2SO4 reacts with 2 moles of NaOH gives Na2SO4 plus 2H2O. So for 1 mole of H2SO4, 2 moles of NaOH is involved in the reaction. So that only we take here. Molarity of H2SO4 is 0.2. Its volume is 200 ml. Its number of moles, only 1 mole is involved, so that 1. Molarity of NaOH that we have to calculate. Volume of NaOH is given, that is 100 ml. Number of moles of NaOH is given as 2. So that it goes here 2 times. Now M2 is equals to, just multiply this, 0.2 into 2 into 2. So this is equals to 4. 4 into 2, 8 into 10 power minus 1, or else 0.8 molarity of NaOH is required for the complete neutralization. Let us see another type of the one where 2 solutions are mixed. So these 2 solutions may be of same types or of the different types. Let us see both the categories now. For mixing of 2 or more solutions of same solute. Same solute means here you can take either acid or base. You cannot take the acid and base. Now let us take here the formula. Final molarity equals to M1 V1 plus M2 V2 plus up to so on divided by V1 plus V2 plus up to so on, or else total volume of the solution. Final volume of the solution. So here, based on the terminology, we use either V1 plus V2 or else we use the total volume of the solution. Let us take those examples here. So in the first one, 100 ml of 0.1 m HCl is mixed with 100 ml of 0.2 m HCl. What is the molarity of the final solution? So here 2 solutions are given. M1 value 0.1 first solution. Its volume is equals to 100 ml. M2 value second solution 0.2 m. Its volume is also equals to 100 ml. You can take the different ml if the different value is given in the question. So that the final volume of the solution equals to M1 V1 plus M2 V2 divided by V1 plus V2. M1 value 0.1, V1 value 100 plus 0.2 into 100 whole divided by 100 plus 100 means 200. So this value here it is 10, this is 20, total equals to 30 by 200. So that it goes 1.5 and 1.5 by 10 is there. That means 1.5 into 10 power minus 1 m, or else you can write 0.15 molarity of the solution. Similar question, let us change the terminology and see how to use it. Example 2, 100 ml of 0.1 m HCl solution is mixed with 100 ml of 0.2 m HCl, and the solution is made up to 1 liter. Find the molarity of final solution. So the question here is, M1 value same 0.1, V1 value equals to 100 ml, M2 value again 0.2, volume is also equals to 100 ml. Now molarity equals to 0.1 into 100 M1 V1 plus M2 V2 0.2 into 100 divided by V1 plus V2 we cannot take. Why? Because the solution is not stopped at this stage. Afterwards, they again added some amount of the water and made the final solution is equals to 1 liter. 1 liter means it is equals to 1000 ml. So that we have to take the final volume of the solution, that is 1000. So if water is not added, you can take the V1 plus V2. If it is made to this final some amount of the solution, then you have to take the final volume of the solution. So now it is equals to 10 plus 20 by 1000 means 10 power 3, 30 into 10 power minus 3, so 3 into 10 power minus 2 molarity, or else 0.03 molarity. So like this we can solve the questions when two solutions of the same solute are mixed. Now let us see if the solutions, if two or more solutions of different solute are mixed. So for solution, for mixing of two or more solutions of different solute. Different solute means here solutes react with each other. Solutes react with each other. So let us consider the case of acid and base. So in this case, neutralization happens. Acid reacts with the base, so neutralization happens. Final solution could be either acidic or basic, depending on the total M1 V1 value or M2 V2 value, means number of moles of the acid and number of moles of the base. If number of moles of the acid is higher than the number of moles of the base, then the final solution is acidic in nature. If the number of moles of the base is more than the acid, then the final solution is basic in nature. Let us see the formula here. Final molarity of the solution is equals to M1 V1 minus M2 V2 divided by V1 plus V2 or total volume of the solution. So here, which one has to be taken as the M1 V1 or M2 V2? So M1 V1 is always higher value. M2 V2 is always lower value, because concentration never be negative. It is either 0 or positive, but never be negative value. So this higher value may belongs to the acid or base. This lower value also may belong to the acid or base. If a higher value belongs to the acid, the solution is acidic in nature. If the lower value belongs to the base, then same acidic in nature. If higher value belongs to the base, then it is basic in nature. So let us see here. If M1 V1 of acid is higher than the M2V2 of the base. The solution is acidic and pH of the solution is less than 7. If M1V1 of base is higher than the M2V2 of the acid, then the solution is basic in nature, pH value is greater than 7. Let us see some examples to justify these formulas. Example, let us take 100 ml of 0.1 mHCl is added with 100 ml of 0.5 NaOH solution. So find the both molarity and nature of the final solution. So solution now. First of all, let us multiply the molarity and volume of the acid and base separately. So for acid, molarity 0.1, volume 100, so this value equals to 10. And for base, molarity 0.5, volume 100, so this value is equals to 50. Whose value is higher? Base value is higher. So the nature of the solution is basic in nature. And they asked us one more thing to calculate the molarity. So molarity of now NaOH, because the concentration of the base is more than the acid, so that final solution is basic. That's why here whatever the molarity we are going to get, that could be the molarity of the base. So here M1V1 minus M2V2 divided by V1 plus V2. M1V1, I told you already, you have to take the higher value every time. So higher value is of the base. So 50 minus 10 divided by V1 plus V2 is equals to 200. So this is equals to 40 by 200. It goes like this. So 2 by 10, that means 0.2 M molarity. Molarity of the solution. So like this we can use it. Similar way, if the solution is made to the some other volume, that value we have to take instead of the V1 plus V2. So sometimes they give the percentage weight by weight and ask us to calculate the molarity of the solution. So molarity and percentage weight by weight are related by the formula percentage weight by weight into 10 into density of the solute into divided by molecular weight of solute. Example, 98% weight by weight H2SO4 solution has density 1.84 grams per cubic centimeter. Find its molarity. So that here molarity of the H2SO4 is equals to percentage weight by weight is given, that is 98 into 10 and the value is 1.84 density grams per cubic centimeters. At the same time, molecular weight of the sulfuric acid is also 98. So 98 cancel out, so molarity equals to 18.4 M. And what happens if percentage weight by volume is given? How this is related to the molarity? So percentage weight molarity equals to molarity equals to percentage weight by volume into 10 divided by molecular weight of solute. So let us take an example here. So 9.2% weight by volume of ethyl alcohol solution molarity is. So they are asking molarity. So here ethyl alcohol molecular mass C2H5OH, 2 carbons are there, 2 into 12 equals to 24, and 6 hydrogens are there, 6 into 1 equals to 6. So this value equals to 30, plus here 16 is there, so that value equals to 46. So now molarity is equals to percentage weight by volume is given, that is 9.2 into 10 divided by molecular mass 46. So this value is equals to 92 by 46, it goes 2 times. So molarity of the solution is equals to that value, that is 2. So like this we can calculate the molarity concept. I hope you understand this lecture. If you have any doubt, please do write to the classroom.point@gmail.com. Thank you one and all, and please don't forget to subscribe the channel.